It's January 3rd, 2023, 4 months until RODA. I still had no idea as to what I was going to do for the International Robotics Championship. And to make matters worse, we were in a team of 5 to 6 people and everyone quit. So I had to do everything on my own. The event that set the stage for what my life was about to become was my situation with biology. When I made Abrams, it was because of something I was told directly about my electronics skills. Whereas for biology, it was indirect. I heard rumors that people whom I respected felt that electronics alone were already too much of a challenge for me and that my situation with biology was pretty deplorable. For me, true solutions have real-life applications, so instead of just picking up a book and studying all night to get better grades, I decided to combine my worst with my best. Since I first started programming in the 5th grade, I just fell in love with it. I never got to the point where I could say I mastered everything, because there is no way you can master everything in programming, and by far, I'm not an expert by any means. I code because I adore the feeling of creating useful machines, and not because I want to go to any programming contests or anything like that. With programming being my strongest point, I decided that I should do something that could use a smart integrated system and be related to life. That's how I stumbled across this algae called Arthrospira plantaris, or more widely known as spirulina. I don't exactly remember how I heard about it, but the idea of being able to master and command life just sounded so exciting to me. Now, with that in mind, I just had to do something with it. So I started doing research on what that algae needed, temperature, carbon dioxide, oxygen, nutrients, and eventually came across this word, photobioreactors, or PBRs. It's essentially a machine that supports, grows, and sustains photoautotrophic organisms such as bacteria or, guess what, algae. Starting out, I knew absolutely nothing about PBR's design, and when I did search to see how people would do them, I discovered that they were extremely overpriced. For the amount the market demanded for one photobioreactor at a time, I could make 3 or 2 of mine, and they would be much better suited for my purposes than what they had. And this was the beginning of ORCA 1. I only got my 3D printer like 3 months before starting the project, and I had little to no experience with using a machine like that. Luckily for me, I've been using Blender for almost 4 years, so I quickly started learning how to make nut holders, screw holes, connectors, proper geometry, and choosing the right filament. Fortunately, I chose the Pusha Mark III S Plus as my first 3D printer, and all I can say is that it was by far one of the best decisions that I took in realizing all of these bioreactors. The printer was so reliable that I can count the amount of times that it failed me during the first ORCA, because the first ORCA was mainly PLA, but with the second ORCA I also introduced PETG parts, and that's when nozzle clogging started to appear. But anyway, it's been running for almost 24 hours for some of the parts that I printed for the ORCA 1, and it's been just wow. With 3D printing out of the way, I had to learn about alternating current, because most of the parts that I used on the ORCA 1 were working on AC, not DC, as most of everything I did with Abrams or the Candy. And here it comes, me with zero knowledge on hot, neutral, ground, and all of that stuff. But mainly, I realized 2 things. 1, it's a lot different than direct current. And 2, it's lethal. So I got myself some thick protection gloves, disconnected all the lives, and figured out the best, most affordable system I could use on the ORCA 1 was using relays. Whereas for the design, I decided to print a fully enclosed chamber so as to try and trap in all the warmth inside the enclosure, and possibly be able to mount electronics on the main body as the project continues. Here we're getting into the limitations of microcontrollers. Whenever we're working with a system that requires automation, the first thing that we need to do is check the specifications of each product. And for the Arduino, even though it can power up all the relay modules, it's generally not a good idea to do so. And this is why most of the relay boards have a separate power connector on them, which assumes that you have a common ground connection for your Arduino. And this is so that the board doesn't overheat, and it can also prevent any potential failures. Next are cables and wiring managing. Now, if I were to talk about one of my worst mistakes and nightmares when coming to any project, well, that is managing all the cables that arise. Well, for Abrams and the Candy, it was an incredible mess, and I should have learned how to use and create PCBs. But for this project, even though I should have learned how to create all of that and just place all the connections on a single board, I knew that I didn't have enough time to fully develop a board, test it, even order another version if the first one was bad. Timing had a huge impact on my decision during these times. By now it was the 22nd of January and I barely discovered how to protect everyone around me from what I was doing and how not to fry my cultures. Because yes, I did fry my first culture of spirulina. Because I didn't realize that when you have a heater, it's supposed to be fully immersed in the water that it is in. Because otherwise, it's just going to heat up like crazy and fry your entire culture. My following attempts at reviving the spirulina failed, as I was left with only about 50 milliliters of it, and that was just not enough to be able to start and grow from the very beginning all the way to 5 liters, which was the goal. Not only that, but it was really cold, and by that time my reactor was not yet capable of sustaining any culture, mainly because it lacked an RTC module, thus it wasn't able to execute any timed commands. Since my first culture was now baked, I had to order a new one, and because spirulina is supposed to be wavy, not a straight line, I decided to purchase my new culture from a different manufacturer, using the following reasoning: if it's green, it's good. And when it arrived and I looked on the microscope, I realized that it wasn't wavy nor straight, but rather dots. And I looked on the manufacturer's page, thinking I was scammed or something, and then I realized it was Chlorella Vulgaris, not Arthrospira plantaris aka spirulina. And that was because I thought that whatever is sold on the market and is green and it is an algae is going to be spirulina. Well, no, there are a lot of different species which you can purchase and grow, and I was incredibly wrong. We're getting really close to the end of March, and this is how the ORCA one looks like. Fortunately, the requirements for spirulina and chlorella were roughly the same, so what I envisioned for the first species on the bioreactor could be applied to the other one as well. This is one of the greatest and by far my favorite features about PBRs, and that is that they're customized to the culture's needs. With the LED strip, the light bulb for additional light, the heater, and the Arduino with an RTC module now working, it was time to test my invention, and with that being said, you're about to watch the results of 2 months of hard and dedicated work, and I hope you'll enjoy it. As you've seen, the results were amazing. To go from 200 milliliters to 5 liters of culture in just 3 weeks is, for me, just incredible. I wrote and adjusted the code in the first 1 to 2 weeks, and since then it has run continuously for about 2 months in total, 24 hours a day, 7 days a week. The quality and longevity of something engineered, 3D printed and assembled by a single person was just wow for me. And that is even though most of the features that it was capable of were not yet implemented, even though the hardware was there. It's just that it hasn't been implemented, and it's likely not going to be implemented in the future as well. This is because the ORCA 1 was my Kickstarter project. It was a great opportunity for me to learn proper 3D printing, alternative current, algae growing, and even a bit of camera streaming from my failed ESP32 integration fails, which I did not talk about. And even though there were so many resources and hard work put into the ORCA 1, by looking at it, I just realized it was not enough.